Hello guys, scanning tunneling electron microscope. Probably the microscope that has revolutionized in order of obtaining the nature of surfaces of materials, their morphologies, uh, the structures involved in those materials. In this video, I'll not be talking about the history that's involved in probably uh, getting this scanning, tunneling electron microscope, how it came in action. But my point here is that I'll be talking about the principle and working of scanning tunneling microscope. Now, to start with, tunneling electron microscope is an advanced imaging instrument that utilizes the phenomenon of quantum mechanical tunneling to generate high resolution images of sample surface. It allows us to study the atomic and molecular structures of materials. The very first important point that I should be talking about this STM is that this tunneling electron microscope it starts with an electron source that emits a beam of high energy electrons, and the electron source is typically a sharp metallic tip known as probe or tip simply, made from conductive materials. Most probably it's made of tungsten. So the next important thing is about the substrate. The probe is brought very close to the sample surface. You can see here, and probably in the range of nanometer scale. And then a bias voltage is applied between the probe and the sample, creating electric field. So now we can see that this tip has to be extremely sharp, and the gap between the tip and the sample is extremely small, of the order of nanometers. So this certainly develops the electric field and becomes a reason for quantum mechanical tunneling. So now, due to proximity, there's approximation between the tip of this probe and the sample surface, uh, and applied voltage, the voltage that's being applied, uh, it causes quantum mechanical tunneling. So quantum mechanical tunneling allows the electron to pass through the potential barrier formed by the small gap between the tip and the sample. A small fraction of electrons from the probe tunnel through this gap and reaches the sample surface. As the electron tunnels through the gap, a weak electrical current, what is called as tunneling current, is generated, and the magnitude of this tunneling current is exponential, dependent on the tip distance from the surface. Now, the magnitude of this tunneling current is exponential that I was talking about. Now, the feedback. Okay, so the current is flowing now between the probe and the surface of the sample. This tunneling current that has been produced is measured and used as a feedback system to control to control the tip sample distance. Okay, so this tip sample distance is controlled by virtue of feedback system. So what happens here? So by maintaining the constant tunneling current between the tip and the feedback system uh, adjusts the tip height to keep it at constant distance from sample surface. This feedback mechanism allows for precise control of the tip sample distance, enabling imaging at the atomic scale. And next point here is that the probe is a raster scanned across the sample surface, typically by a piezoelectric scanner, and to collect the data points point by point. The variation in the tunneling current are recorded and used to create a topographic scanners here, and when this current is developing those maps of surfaces, the variation in the tunneling current are recorded and used to create the topographic map. And finally, what is happening is the resulting tunneling electron microscope systems. They provide the images, and these images are displayed. They are processed and they are displayed on the screen. So there are a couple of things that are important to keep in mind. The very first important point is that this whole system should remain in vacuum, because if some kind of air molecules are present in the system, the scattering can occur, and that scattering may damage the samples that we are supposed to investigate using scanning tunneling electron microscope. And the next important point is that this STEM should the tip and the sample gap, this should be conductive to facilitate the flow of current and enable the quantum mechanical tunneling. So, in summary, I would like to say that the tunneling electron microscope relies on quantum tunneling phenomenon to generate high-resolution images of sample surface. So, by controlling the tip sample distance and measuring the tunneling current, we can visualize atomic scale features and study the properties of materials with exceptional details and results.